right? Let's begin. All right. So today we have Dr. Steve here from Sutton Tools, right? So
hello.
So I think I don't have to introduce the concept of Industry 4.0 to you, right? It's better you tell me what it is. No, I'm not going to ask you to give me a lecture here. So how about let me know. How would you describe this company right now? I mean, its position right now, is it right at Industry 3.0 or 4.0?
I think that's the wrong question, but anyway, that's another story. There is mix within this company. There's levels of definitely 3.0. There's levels of Industry 2.0, if you want to say. There's levels of Industry 1.0, I think, in certain places, and that's the point. There's a mix of industry. Even within one company, there's a range of machines and devices, legacy systems, machines that are paid for, processes that are very manual, processes that are very automated. ERP system that could be integrated further. Pockets of complete systems front to back, top to bottom, across supply chains. We have an API manager based around a data that's in an Oracle database for marketing purposes to complement the data in the ERP system that is completely self-serviceable by customers. But not necessarily customers at Bunnings, but business customers and their systems. So we change the data on our website. That is automatically or immediately reflected in the API that, say, Bolt Industrial would have on their website for their products. So, I think that question could be answered by you'll find parts of Industry 4.0. I'll keep talking. Industry 4.0. Potentially, you could argue that no one is going to get to Industry 4.0 until maybe 2030, because that concept of the self-optimizing system or the self-ordering system or whatever. But we do have pockets of immediacy and transparency of process, where the processes are immediately available to see what's going on, and also forecasting as well. So, which includes a very simple model of the process. And all right, to keep the conversation going, when you're looking at models of if you have a complex process, you end up with a complex model. Whereas if you're looking at very simple data, it's very simple equations that can model the system.
Right.
All we need is sort of time information and maybe one or two bits of information about the product, about the system, to give us that management information that we want. And it's a work in progress. It's like lean manufacturing for us, for Sutton Tools. For me, Industry 4.0 is a work in progress, and it's not something you can buy and apply and forget about it. You have to work on it.
Yeah. So what are the difficulties you have encountered when you set up this system, or your team set up this system?
Difficulties, okay. Some of the difficulties initially were with trying to use solutions from companies that notionally were providing solutions. The difficulties are often down to understanding what data you want to collect, and then managing that and pushing it around the network. The difficulties were.
What do you mean by the network? You mean the communication network, or
communication network?
Literally
Literally communication network. One of the things we looked at initially was a 4G solution. And looking at the data we were generating and realizing that, hang on, we've got gigabytes of data. I wouldn't want to be paying the phone bill for that.
Right.
And what was I going to do with it? So, and then we had a relationship with Oracle, and so it was clear that companies like Oracle have products for IoT products and cloud-based solutions, but the difficulty is that connection of the machine. Well, there's a guy from Charles Peterson, I think he's called, talks about the last digital mile or the last digital room, and that's the critical bit. The point is that that connection, if you don't make that connection, whatever system or toolkit you've got are useless,
right,
because there's no data to populate it. And it's that making that connection. So what we've done here is trying to look how easy it is, how cheap it is to make that connection. And finding solutions that make that connection, because if you don't do that, then you're not going to get anywhere. And also, we focused on, or I focused on the dashboard, the visualization tool, because that's, if you, there was a Gartner report, I think 2016. Was it Gartner or was it another group? But anyway, there's two studies that sort of in the US and Europe that come to the same conclusion that essentially, regardless of where you're on the journey of Industry 4.0, there's a number of solutions in warehousing and in logistics and processes that boil down to the same type of technologies that's in a dashboard. If you can produce a dashboard, then the other ones come out of it. So it's the dashboard is identified as a simple first step that had all the ingredients for Industry 4.0 to move forward on. So it's a good vehicle to base Industry 4.0 activity on.
So we will get back to that dashboard later. So get back to the hardware stuff. So a lot of stuff are being built right here in-house, right?
Yes.
So what kind of devices are you using by picking them? What kind of standard? I mean.
Yeah. Okay. Well, did some research on the areas, and it was trying to find the cheapest. Well, okay, the network is sort of essentially, what we've done is overlay a sort of wireless sensor network on top of the machines.
Yeah.
If we were going to do that, the initial thought was to use Arduino, because there were some devices on there already.
Yeah.
But then, of course, the Arduinos would need to communicate with some, that data would have to come from them to the rest of the system. And after some digging, it was basically an XB, which is a company called Digi manufacture this thing called an XB, which is a device that either can use, well, the latest ones can use Bluetooth, low energy, Zigbee, 802.15.4.
LoRa.
No, it's not. Actually, it might be, but maybe another device. But yes, and some sort of low range, that sort of low energy sort of radio, whatever it's called. But within the plant, that sort of either Zigbee or 15.4 network was something that we could do, and these devices had enough I/O on them.
Right.
So they had it was a device that didn't need to be programmed; it could be configured remotely with I/O that could be deployed on the machine without even paying for an Arduino, even if an Arduino was very low cost.
Right, but at the same time, XP solutions are not cheap.
No, they're $20 a pop. But that's cheap relative. I mean, we initially wanted to look at the initial project was one to measure grinding wheel power consumption, and it was quite a complex waveform. 25 samples a second was the minimum data rate we felt we could use, but it's $1,000 per spindle. The signal conditioning device that we've got are relays. So we're connecting to every machine. We're connecting to basically a no voltage contact, a dry contact. So that for me is the lowest cost sensor, because even though sensors are cheap and people go on about mobile phone sensors. Well, in fact, mobile phone sensors seem to be the ones that people use, because you can buy for a few cents you can buy a barometer, a temperature sensor, what have you, but they aren't real, or accelerometers. They aren't the sort of sensors that you need in an industrial machine. In fact, it's sitting on the desk somewhere there, but $200 is about the lowest price oil pressure sensor that you would want to put on a machine in the pressures we're using.
Right.
So yeah, it went from $1,000 for the power from an inverter to $200 for oil pressure sensor to either no dollars or a few dollars for relays that either exist already in the machines or can be added without having to get into the PLC programs. So that was it. It was to try and put a very lightweight, especially with machines that don't even have PLCs. So there's no PLC reprogramming, no interference with the existing control system. It was all right. The bottom line is there's about 3 risks that are identified that everybody has: skills of the people, the cost of the systems, and that's sort of related to, and security. So if we avoided those 3 pitfalls, that was the aim, was to find a solution that avoided those pitfalls.
Right.
Whether or not we've achieved it fully or not, I don't know, and I think potentially now we'll know a bit more about it. Some of those skills criteria, there's still a level of skill required, but you can find it in graduates.
Right.
In fact, that was the aim. In fact, that was the very first project in 2015, was to do it with a graduate. And the commercial solution failed because it was closed source. We couldn't get enough information. It was limited in scope because we couldn't integrate it we couldn't change its integration because, again, closed source and also compiled not for low cost machines. And so it was a roadblock. The cloud application was usable, but all the bits that tripped you up about the integration between the steps were exactly the same trip-ups as we found with the open source system. So if you can solve them in an open source system, why find them again in the closed source system and pay for the privilege of doing that? Is really what I should say.
Right.
So yes, that's why I ended up with this open source solution. So yeah, that's where we are.
Okay.
There are problems, of course, and it's all about change management. The issues are maybe cease to be technical and start to be sort of systematic, and they're the issues, and that's one of the reasons why the penetration of Industry 4.0 is potentially low. Okay, it's been oversold, but what can be done right now is process information. We can find out immediately process information, and if you want to find that out, it's quite doable with the technology that's available, and of course using the network-based tools, this internet type tooling. It's talking about web pages for your front ends. The browser has become the sort of the BBC Model B or the Sinclair Spectrum, or whatever it was, the ZX81. The cheap computing system that everyone could go for.
I know.
And so now you've got your browser, with JavaScript built in. You don't realise what you've actually got on your desktop.
That's right.
And that's it. That's the penny drops when you realise and how these things connect together with services. So it's RESTful services, SOAP-based services, databases that can create that sort of those types of services very easily through configuration, through button clicks. Is really what allows us to do what we do. And that was the concept of skill sets. Using these RAD tools. That's what we focused on. Again, there are more what would you call personality, business, change management things that get in the way. But I think one of the things that I try to do with Suttons is to try and expose. In fact, that's where the conversation started because unless you're showing people what things are what you can do, the penny that they don't sort of see, and then they don't have that next. If you've got that, then maybe I could do this. And so it's. If we were to have started off by doing this through a board-based decision process, it would look quite a lot different, and there would have been a hell of a lot more investment. Maybe a lot more risk being taken, but possibly done quicker. So because there's an outside consultant, you can beat around the head if they don't deliver. But still, you've got to know what you're going to ask for, and that was the other thing as well. This project, I think, allows a company to learn about what's possible. And then to make better decisions.
Right.
So even if it's not quite Industry 4.0, it's Industry 3++. It's like, you're getting somewhere.
Right.
But again, to sort of reiterate, maybe go over old ground. We're talking about processes that have been carried out using paper, using whiteboards and marker pens. So if you're going to replace those, you can't replace them with a very high cost substitute.
Yeah.
So it's that $70 a month figure has been mentioned. I mean, Movus as well. That's another device you can this buys a service. It's a vibration monitor. $70 per machine. So per month. So that, and again, subscription service. So you've got to justify. If you put that on a machine, you've got to make a saving somewhere. So is it to do, what's it going to be that you do with that saving or that 70 you spend? And potentially it could be you could then push out your maintenance schedule. You can do it more on demand rather than over-maintain your systems. So that value is where things are possibly missing at the moment.
Right.
And I think there's There's an article. Do you want to stop? There's an article that you maybe ought to. There's a Forbes article about why IoT fails, and that's a useful one because industries, as we said before, industry 2 to industry 3, and to sort of then to try and change that, it's a big ask. If systems have been created and when they work, and companies are successful, then they're going to have to change something that works to something that they have to invest in, and that has to be. You have to be able to demonstrate what value that's going to give them.
So let's say, because you're expert in this area, but say for other local SME, if they really want to adopt Industry 4.0 or even just back to 3.0 technology, which type of solution should they start with? Open source, closed source. Closed source usually with more support, open source more flexibility, expanding later on. So what would be your suggestion for?
Well, there are integrators using open source products because what the difference is the license fee. So even if they found an integrator who used open source products and RAD tools, they would give them the best outcome potentially. They've got expertise in the field, but they can also part of that fee isn't a fee for service or fee for licenses. So you then back to paying for time. So it might even be just an education process that there are open source solutions available to you that aren't delivered by, you don't have to do yourself. You can have an integrator do that for you if they use those things. The negative about that is that that's another thing that they can't sell you. And if the product becomes so cheap and so quick to implement, then it's almost impossible for them to make any money selling you it. So that's the other disruptor. In fact, I think that Charles Beeson guy talks about that too. That you get by putting some of these systems on the machines that you do to look at process improvement or process transparency, you get everything else for free. So you've turned it into a commodity. It's a very low cost thing that you've done to give you huge amounts of value, and again, very hard to sell. So it's quite disruptive. So the technology is disruptive not only to the business that's put it in, it's disruptive to the people who have made lots of money on Wonderware licenses and what have you for the last goodness knows how many years. Those types of things, and that's where it's the short term. The short and long term has been mixed together when people talk about Industry 4.0.
Right. So currently, you're connecting those machines that are relatively old.
Yes.
Right. How about those new ones? Those new ones have their own system.
They're easy to connect to. In fact, there's no issue with the new ones really.
Is there any problem with the format of the? Are they compatible with each other? Will there be a lot of conversion that we need to do at the middle?
Yeah, that's an interesting point. It depends what you want to take out of them. Often we've just looked at product counts, and it's actually the raw data and letting the database work out what that count means is quite straightforward. With a system that might have an OPC UA server on, for example, you've got to interface that server. It might be called counts on one, it might be called count on another, it might be buried in a different hierarchy. So there's a lot of the discovery of that service endpoint will take time. So right now we've looked at legacy because legacy was potentially one of the higher problems, but I actually, in some respects, also think it's one of maybe the simpler one if you put a purer layer on. However, having said all that, we did apply the same devices to a machine with a modern controller, and just picked up a couple of relay outputs that existed, and we put the exact same system on.
Right.
So we didn't bother, because the machine understood count, it knew how many parts it had made, but we didn't even bother getting that data. We used the system that we've got to basically count events and then work out from those events whether it had made a part or not. So we applied the same tool, the same device to a more complex machine. And that's the other thing, is that a lot of the OPC UA functionality, it's over the top for when you're looking at just management of machines. You don't want to know the tracking error or the following error of your encoder necessarily. Right. You want to know how many parts you've made, what it is you're making, what state the machine's in.
Yeah. So
You can get more.
actually, it really depends on what kind of data you want to get.
Yes, exactly. I think that's the bit, and maybe that's the point that people need to understand. They need to have a really deep look at the data that they want to collect, and not just that, just not the data they want to collect, is maybe even take a step back. What they want to know from the business. What is it that they want to know, and then that leads to, well, what's the minimum bit of information I need from a machine to know that, and then it all leads from there. It's not like, hey, I've got a spindle temperature, let's put it on a board, you know, because it's, what's the point?
Right.
For what purpose? For what end? Yeah.
Right. But for those data, do you have to actually tap into the system, or
Well,
can get through from its interface without modifying the machine?
modification of the machines, the maximum we've had to do is just the engine, the electrician has had to wire in a second relay. But we've tended to pick up, because we have 2 bits to play with, we tend to sort of use those for collection of data. So it's whatever you want to do with that. I won't go into too much detail about what we do with that, but it's quite straightforward. And the point is that, you know, you want to trigger an event, and the event is then analysed for us. We just take in a pusher signal, for example. So when that pusher operates, we know that a drill has been pushed into the machine. It's a pulse. There's an event occurs.
Yep.
And we just monitor that pulse train. And that's it.
Okay.
And everything else gets built from there. So that's the simple, very, very simple.
Right. Okay. So back to the dashboard. So dashboard is about how we visualize the data.
Yes.
Do you have any thoughts on that? I mean, right now people are just mainly showing numbers on the same screen, but
Well, we try to.
do we need some other skills in order to present them in a more meaningful way?
Oh yeah, look, I think.
Or can you find? I mean, do you find any difficulty in finding suitable person to do this kind of job? I mean, do we need, say, some more training for people how to actually know how to visualize high-dimensional data?
Yeah, that's a really interesting one. High-dimensional. I mean, high-dimensional data.
I mean, anything more than 3-dimensional.
Yeah, well, yeah, then you've got colour and it's a big deal. Yes, absolutely. But maybe if you're starting to want to visualise that, it's a bit more complicated than you're going to get from a machine. But we relied on what the floor wanted. So the design was based on what the floor wanted, and the traffic light went to having 3 lights with 1 greyed out to actually a single light that changed colour. So it's green, red, or amber. It's a big circle that's visible from the front to the back of the factory.
Right.
We have a gauge, we have numbers, but we also have a visual gauge. It starts off red when it's empty, goes through sort of yellow, and orange to green, and then when it goes over the top, it writes over in a darker green, so you know it's gone around again. So visualization is very important, and quick glancing at a screen. So the tool kit that's available, a lot of the tools are sort of fairly well understood, or not fairly well understood, but fairly well represented in a basic dashboard. One of the nice things that we've got that one of the students did, and we talk about who can do it. Well, Matthew was a student, hadn't graduated, knew a bit of coding, used Node-RED, and we started off with the built-in tools that were in there, their own sort of nodes for graphs and what have you, and then quite quickly we moved on to writing our own in CSS and HTML. So CSS and HTML5, which is obviously what those were built on in the first place, after a short while we were able to, well, I should say that Node-RED is a rapid application development toolkit. It uses flow programming. You drag a node onto a sheet and wire it together, and the data flows through it.
Right.
Interspersed with that, you can add snippets of function blocks or functional code that act on the data stream. So you end up writing little bits of code in there. As you get better, you can write more code or less code, and you can introduce CSS or templates for the HTML, and you can use a mustache. What's it called? The mustache sort of agile. What's it? Agile. There's a couple of JavaScript libraries that use a particular notation that it makes use of. So as your skills develop, you can start to replace some of the built-in nodes with your ones you write yourself. But it's a process, and you can create dashboards with very little JavaScript programming expertise, because you're just basically configuring the systems. So that's the skills. The visualization, of course, is very important. You maybe can't overanalyze it to start off with. Potentially the best solution we found was actually presenting something to people and saying, what do you think? So it's there was an agile sort of iterative process that we showed something, someone commented, we changed, and then one of the nicer things I say was basically a circular display which that it's a filled radial chart that represents production per hour, so you can see at a glance, how many parts you made per hour. 10-day moving rolling averages, that type of thing. Those are sort of stuff that people want to see. Utilization graphs, machining versus machine.
Right.
So dashboard design is actually very important. Having a screen that looks like a spreadsheet isn't that useful on a visual display, but it might be handy on your desktop, for example.
Right. Or
But then-
machine learning.
Yeah. But the other thing, of course, is if you want to look at it with a tablet. So then you get back to all of the issues with, responsive and reactive displays and all this sort of thing. But all those things have been talked about with applications. That all we're doing essentially is piggybacking on those developments for apps that has gone on an app deployment. We're using the same framework to allow us to do to put our to create our industrial applications.
All right.
So that's it. That's the advantage. I think that's why there's charts on Industry 4.0 that show complexity going up. I actually think that complexity has taken a massive dive down in maybe the last 10, 15 years, maybe not even less than that.
Right.
So it's much easier for people like myself to actually create these things than it would have been 20 years ago. It costs a lot less,
Yeah.
which is my time. The skill sets are lower.
Yeah.
The entry, no, that's maybe not quite
Lots
true.
of tools available.
The tools are available and the information is available, and the starting points are there for you. You don't have to roll your own. There's
the entry barrier.
the
is
entry.
lower.
That's right. The entry level is really, really low.
Right. Right.
And then once you've entered it, of course, then you pick things up and you realise the mistakes you've made and what have you.
Right.
But the entry level is low. It doesn't help. SMEs are not going to maybe take that plunge unless they can see examples, and it's back to return on investment. They want to know how they can make money on these things. Instead of spending $20,000 system, if they spent it on a new product, that might be a better thing to do.
All right. I mean that's the next point I want to raise is that, well, for your case it seems that it's so good that you know exactly what the factory floor want, what kind of data they're looking for. I mean, this is some sort of luxury. I mean, most of the time people don't know what they want.
No, that's true, but it took a while to get there.
Yeah. How did you convince them to start building the system? I mean,
if you look around at the paper, you look around at the reporting systems that they have already. That the advantage of Suttons is that they're not heavily into lean. I wouldn't whether they're the best embodiment of lean manufacturing, I don't know, but lean manufacturing is I think especially in Australia and New Zealand, it's something that's very well taken up. There's been it's been a movement from sort of total quality management in the 80s through to Six Sigma, through sort of various iterations, and now lean manufacturing. But the lean manufacturing toolkit, statistical tools, data-driven manufacturing, data-driven decision-making, and which is no different from all the quality system talk that was there in the 90s and earlier. But those are foundations and fundamental bits, and tools that can automate those processes, I think, are where the business of people providing Industry 4.0 solutions is where that is now. And I think the big SCADA systems, they give you those dashboards, they give you that information about the machines and processes, but the costs have always been very high, and so they were available to the sort of the 400 or 500 people size companies,
right?
Whereas now with Industry 4.0, these tools are available to the 20 people companies, that I would argue still, of course, it's a time-based issue, you know, and that value concept is really what you need to know. But even if, and that's where I talk about this, you know, if you're a small batch manufacturer and you haven't got an automated system, but you want to know where things are and you want to give value to your customers, this is where the toolkits can come in, and the same tools you use on the floor to improve your visibility of your process, if you expose them to the outside world, means that someone can find out, just like you can with your iPhone or your watch or your Apple Watch, where it is in its manufacturing state, just for nothing, because the company's put it in place, and now by putting it to the outside world, it makes it feel that you feel special as a customer. Servitization. In fact, it's servitization, and that's the other thing I should maybe mention. That the drive for this as well was a few years ago was servitization. How can we servitize what we do? How can you make things a service? So yeah, I don't think there's nothing. Whether Industry 4.0 is sort of brand spanking new, or whether we've just bent it to fit the servitization model that we were aiming towards. But they fit very well, and the same tools are there.
Right. So, collect the data. How are you going to use them? Or any plan for using them?
Yeah, that's the bit that's not fully exploited yet is the reporting capability. We've got this huge time-based data set that gave you immediate visualization. Currently, the reports that we have are on the screens where we have, monthly utilization, monthly to target, sort of that type of information. But it could be very easily, reports can easily be generated to give you more business information. So rather than sort of paper-based sort of systems, or I should say spreadsheet-based, the database toolkits are available to you to create sort of ad hoc type reports, or an interface with a report that you wouldn't even need to design it. You could just put it together from all the drop downs, for example, of all the categories that you measure, give you some huge reporting capabilities to look at how your business is going. And that's the area where the next stage of development will be, and that will be for us as well, simplifying the way we've structured the data. Because if you want to, part of the process and part of the difficulty, and that isn't going to be obvious initially, is that no matter what type of system that we make here at Suttons and want to try and sell at Suttons, it will need tailoring to the next company down the road. They aren't making drills. They might not. They have a different machine sets.
Right.
So there's a customization or a configuration part that needs to be straightforward and low cost in order for it to work with them. And again, they might say, well, I don't want a dark sort of theme on my dashboard. I want a bright theme on my dashboard. I want my company colours on my logo. So all those things need to be easy to change and built in. And again, that's good database design, really. And I keep saying database because ours is backed by a relational database, and that's the bit that, if you had to sort of point out what skill sets, you alluded to it earlier, I didn't really answer it, about who you would get in to do this. I come from a mechanical engineering background, but the skill sets that are missing, I think, in mechanical engineering are that, and again, it's not necessarily computer science, it's more to do with maybe software engineering type stuff, where it's database skills, persistence of data, that's the bit that's missing out of a mechanical engineer's background. Statistical analysis to some extent, because I think stats has maybe fallen away. Programming, and not MATLAB or MathCAD or whatever it's called, because no one can afford that in industry. But it's also fairly sort of specialised. Python skills will be good for people. JavaScript, scripting type languages.
Right.
Some skill in that would be very useful. In fact, Python's a really good one. As a visualization tool to replace even MathCAD. MATLAB, sorry, not MathCAD. That's a bit some of the 20 years ago. Yes. So look, there has to be a business requirement. I think that's the bit. That's and it's not technology. It's not cloud based. It's not some of those things help to give you quick solutions. It means that you don't need to have a server yourself, but again, it also means you have to expose your data through a firewall, for example. You know, if you do it yourself with low-cost gear, you can keep it all on premises. There's no need for data to go to cloud. And that's where we are. But yeah.
So is security a huge concern here?
Security is, well, actually security is a good one. I think one thing that we identified with security wasn't just security of data, but security of systems. We deliberately don't have any action control. So there's we can't remotely operate a servo or an actuator or anything like that. We can't turn off and on production. We're just monitoring. And the loop isn't closed. It's closed by the people. So that's a risk, a health and safety security type thing. Then data security is another interesting thing as well. We keep everything behind our company firewall. It can be accessed from outside, but that's via VPN. We don't expose that information to anybody outside. The network itself could be insecure as well. We've tried to configure it so it's not, but you know, we aren't, and that's the other area we might need an expert in computer science to sort of go. Well, even the simple choice of what channel to sit your network on, you know, might be something where we would use we would need someone from outside to help us.
Right.
But we don't see loss of data happening.
I see.
And there's a Raspberry Pi on the windowsill over there. That's the end of the star, or the middle of the star, I suppose, in that network.
So, let's say change the topic a little bit to social issues. So people worry about Industry 4.0 or any kind of machine learning AI that will take their jobs. So what do you think? I mean, or what do they need to equip themselves with some new skills in order to work with robots or technology?
All those things that you can answer in any the positive or the negative, I think. For us, the success was to actually integrate it, was to sort of maintain a connection with the shop floor in terms of the design of the dashboard. And in fact, the first time we put it up, a lot of people said how good it was, because they'd come from, say, automotive, where it's second nature to see dashboards everywhere on production, and thought, well, that's good. So it's been accepted quite positively. If we were, and we have robots on our lines as well, there isn't one person per machine as you would have seen in the 70s, for example. Not, in fact, all the way through to even the 80s and 90s. You know, it's there's maybe one person managing 2 or 3 machines, or maybe five machines. So there are robots that have taken people's jobs already. To talk about AI in this application, well, that would impact potentially the office side of it. I think the people who would worry would be people driving spreadsheets and just dragging and dropping data from one place to the other and producing graphs, you know, who aren't necessarily adding value to a company. Then again, they would then be able to look at, well, what probably, you know, instead of producing the graph, they would be then looking at what is driving the data in that direction. So they could use it could be enriching. So regardless, it wouldn't necessarily, you know, make them redundant. It would potentially support their role. Now, whether or not that can happen to everybody. I mean, for example, if we employ cleaners. If we had a robot cleaner, you could then dispense with a few cleaners. So that would displace people. So yes, there's potential for displacement, absolutely, and but there's also potential to enrich the data that comes in, and plus companies look at productivity improvements. You know, if a company like Sutton Tools can manufacture drills and taps and end mills in Australia profitably, it's a family-owned company, they've been doing it for 100 years. They're selling overseas. If they didn't maintain a level of productivity that they do, then they could easily be replaced by imports. You know, somebody else in another country can step in and do the same thing, which again is, I think, a drive for Industry 4.0 from Germany.
Right.
we haven't talked about it, but I think that's another issue, is that Industry 4.0, as Australia has adopted it, I think is too focused on the German model. And because it came out of automation and trying to maintain Germany's role as a leader in automation and then some and manufacturing, it's potentially not quite appropriate to use the same tools and techniques in Australia as it would be in Germany. The business sizes are different, the mix of manufacturers are different, the types of manufacturing is different. The raw or underlying aspect of looking at productivity and improving that is the same, of course, but there's some of the tools that have been developed for the German model are a bit too rich in a sense for the Australian one.
Right.
So no, it's all right. So yes, Sashi.
Okay, so how about AR and VR? What are their application in this Industry 4.0?
That's a really interesting one. I'm quite cynical about them, to be honest.
People suggesting use for training or maybe
potential for training,
help worker to adapt to the customization thing.
Yes, that's true. But it's a bit like the use of FEA. If something's extremely expensive to test or very dangerous, or it's car crashes and explosions, then you need a modelling tool, and you need to validate the model. Whereas in an environment like this, potentially where the things are hazardous, we can train people on the job. We can train them on the real machine. So we aren't laying out sort of a vast array of pipes and networks or things like that, or a control. I can see in certain areas it will be absolutely very valuable to give people a visualization tool. It can allow, even in the interesting things, it can even help you furnish your house, to see what things look like in place. So absolutely, there's definitely a role for it. The downside of it is that in a machine environment, where you're looking at a machine, for example, and sort of seeing things going on, you can do that with a dashboard. You could do that with even with a smartphone, rather than a specialised headset costing $7,000 or $8,000. You can do it with other means, and that some of those things are sort of an effect. It's looking for a solution. With visualization, the models have to be, the model sets have to be there, and they have to be counted up. So the effort to create those models has to be around. So so that has to exist in order to have those things. So it's got its place. There are, even something as simple. We mentioned Confluence before. We've done it here. We've put a barcode onto a system. You just scan it with your phone, and it pops a web page that tells you your SOP. You don't need a headset to do that or to look at it.
That's right.
The reason you do it can often be replicated with a simpler system. That's why paper-based charts work so well, because it's no batteries. You drop it on the floor, it doesn't get oily. It doesn't go if it's not out of date. Representing that, having that stored electronically on a smartphone, for example, is or accessible via a smartphone, because it's not actually on the phone, of course, is very doable too, and it's doable now. A VR headset isn't going to help you necessarily. Phone technology to look at an overlay and look through a window on your phone, overlaying some augmented reality, is potentially the way to go as well. When people are immersed in a augmented reality environment, you have to be quiet, because if you talk to them, the command might be interpreted by their headset.
Right.
They're trying to visualize these little pinches and moves in space, and and not concentrate on the thing they're going to fall over. So it's not. it's got a place, and it's very interesting, and it's a great technology. But it's this is a technology that might be 5 or 10 years away from being ubiquitous and useful.
Right.
And it's a showcase at the moment.
Yep. All right. Okay.
Sorry, maybe I should say the things that I have seen that have been useful for is if you wanted to practice, for example, servicing a wind turbine, you know, a few hundred feet up in the air. You know, that's a good place for
Yeah,
it.
yeah.
You know, it's things you can't do safely on the ground. So
Right.
it's finding those, just like FEA, it's finding those expensive, dangerous situations that you could simulate to a high degree to help train people.
So, any final words for other industry that are still planning or thinking about adopting Industry 4.0?
Yeah, what does it? Keep banging the rocks together, isn't it? That's the for all you guys, just keep banging the rocks together. It's that Nike, isn't it? Just do it. I mean, just focus on the very basics. You know, it's if you're in a position in your company to invest in this, you can at least test the water with very little costs. Even still, it's you know, if it's maybe a luxury as well. There's a wait and see game going on, definitely. You know, sounds great, but you know, you go first. You know, you spend your money, and we'll learn from it.
Right.
It's very hard. It's like like lean manufacturing. You aren't going to buy Industry 4.0 in a can. You aren't going to buy an Industry 4.0 device and put it on your machine and suddenly everything will work. It's never going to do that for you. It's going to be the things it can do are expose your processes. You know immediately what's going on. You know, and what you know. Yeah, well, that's it. But that's also a bit double-edged, of course, isn't it? If you know immediately what's going on, you know, and before it starts to lift the veil on what's going on in your plant. So it's good information, but you have to act on it. You know, it's never gonna. It can't. It can only provide you with information that you need to act on, just like lean manufacturing. And that's the final word, I think. Potentially, systems in future could potentially sit down like the Movis system does. It sits there and listens to vibrations for a couple of weeks, then decides that hang on, this is out of the ordinary. It's an AI type solution. That isn't necessarily going to fit everywhere, and I think the issue is that small businesses, although they have similarities, there's enough differences to make it so that there has to be a configuration aspect to any tool they buy, and that's it.
Right, I think that's all from me. Thank you, Steve, for spending time with me for this lovely afternoon.
No problem, Ben. Anytime.
All right, stop here.